All right, this is climate and climate change for natural resources folks, part C. Let's talk about what we know about climate change. I'm going to focus on what the Intergovernmental Panel on Climate Change, IPCC, says about climate. This body is basically develops consensus summaries of climate change for world governments. This consensus part is important. So if you just went into Google or Google Scholar, which is Google's search engine for scientific papers, and just typed in climate change, you would get millions of scientific papers. It would be ridiculous. And it would be very difficult for you to just start reading those papers and get the best idea for what the science says about climate change. So the IPCC group brings climate scientists together to say, okay, given our knowledge of the literature and the current state of climate science, what do we think is the scientific consensus at this point in time? And so that consensus part is important because it's an interpretation of the science. One thing that I'll point out is that these consensus statements are conservative. Okay, this group is not going to say that something is happening until they're sure it's happening. They're not going to say the sky is falling unless the sky actually is falling, because they don't want to lose their credibility. They want to ensure that what the statements that they make are backed up by the best science available. So these are great documents to go to understand the state of climate science. And there have been a number of these reports where these reports come out every 5 years or so. And this is the 6th, I believe, consensus report that's come out. So these are worth looking at. So what do we know? So this is some of my take-homes that I've done by looking at the 4th, 5th, and 6th climate assessments. The 6th one is the one that's coming out now in 2023. And I've used some of the words that they use to characterize scientific consensus. So they use, in some cases, natural language like is or unequivocal or likely to characterize how sure or unsure the science is. Here they used a word called medium confidence to express that, well, maybe the science isn't quite settled or is still working on this question. But a couple of things. Atmospheric CO2 is rising due to human activity. There's no question about that. That is known. People don't study this anymore because we know that's what's happening. The warming of the science or of the climate system is unequivocal. Again, certainly people are studying how warming is happening, but there is no serious question among scientists that it is warming. Warmer and more frequent hot days and nights are virtually certain, and warm spells and heat waves are very likely to increase and last longer. Okay, so those are pretty confident statements based on the science. Altered precipitation regimes are likely, but there's likely to be variation in how that happens. Okay, there's likely to be increased intensity of rainfall events. So what this means is that there may be some places where, for instance, the annual rainfall may stay the same, but that rainfall may be distributed differently. So for instance, we may get 1,000 millimeters of precipitation, but it will come in a smaller number of very large rainfall events. And there may be increased or decreased precipitation depending on location. Precipitation is harder to predict and to observe. It's more variable. So this is basically harder and more difficult science, but there's active research on all this. Another really active area of research is on tropical cyclone intensity, so typhoon and hurricane frequency and intensity. And there's medium confidence that cyclone intensity is likely to increase or is increasing right now. I think there's a little less certainty with regard to frequency of tropical cyclone activity. So these are some good statements with regard to the current state of knowledge on climate change. Getting closer to home, what are some potential effects on trees and forests? Well, if you want to learn more detail about all of these, I encourage you to take a tree physiology class, forest ecology class, but this is sort of some of the broad take-homes. So there are a direct effect of CO2 on trees and forests. So one of those take-homes is all other things being equal, elevated CO2 increases photosynthesis and growth, especially if there's adequate water and nutrients. Okay, so CO2 actually acts as a fertilizer, and all other things being equal, CO2 in some situations has the potential to increase productivity. So especially in some, for instance, tree plantation management situations, in some, for instance, irrigated agriculture situations, elevated CO2 might actually have a positive effect. There's lots of potential indirect effects. Elevated temperature can have positive or negative effects on trees and forests. Altered precipitation regimes, that means there could be more or less water availability depending on where you are, and therefore altered soil water balance. Actually should group, all of these into disturbance. Climate change is likely to alter disturbance regimes, which can have huge impacts on trees and forests. So those frequency or severity of storms like hurricanes, we know hurricanes can have huge effects on forests, and altered hurricane regimes therefore have the potential to impact forests. We know that wildfire, insects, and disease are important disturbance factors in forests. Those also may or likely will be altered by climate change. So again, there's active research ongoing in terms of how climate change is likely to alter disturbance regimes and what that means for how we manage ecosystems. All of this can be a little daunting when we think about managing forests and other ecosystems in the face of all these changes. Fortunately, there's lots of people working on it. Climate change research is central to the research of most forest ecologists, for instance, and there's a lot of good work out there. The U.S. Forest Service is key to a lot of climate change research. They're doing some great research. So this is a site which has developed a tool which allows you to generate Walter climate diagrams for future conditions. Okay, we know what the Walter climate diagram looks like for Gainesville, Florida right now. What will the, given the what we know about modeled future climate conditions, what will the Walter climate diagram look like for Gainesville, Florida around the turn of the century? That can be really useful for understanding how to manage forests. So lots of good resources online. Here's another U.S. Forest Service tool. This is their climate change tree atlas. What this allows you to do is to go in and say, okay, I'm interested in sugar maple. Well, you can create a map that shows the current range for sugar maple, and you can say, okay, what is the possible range for sugar maple 100 years from now? And it will show you how the sugar maple range may, for instance, migrate north in the future. A lot of this stuff is still uncertain, and for instance, I wouldn't bet the farm on a projection of the sugar maple range 100 years from now, but what this stuff does is help you as a natural resource manager think about how, what direction things may change in the future and what you can start doing now to be planning for those changes and for managing natural resources under those changing conditions. So here's some take-home messages for climate change and natural resources. Climate is changing. We have significant data, and we really shouldn't be arguing about that. We should be figuring out what to do about it. The effects on forests are happening and likely to continue. I didn't really dwell on that much in this lecture, but in some of your other classes, you'll learn more about that. Some effects of climate change may be positive. For instance, southern pine plantation productivity is likely to increase given predicted precipitation, temperature, and CO2. But there's likely to be many negative effects as well. Range shifts are possible for lots of tree species, but difficult to predict. Given that, we probably are going to need to be thinking about assisted migration of trees, because tree ranges are likely going to be shifting faster than trees can naturally migrate. We can probably figure this out for commercial species. We know a lot about the southern pines, for instance, and we know a lot about their genetics. We can probably figure out how to move southern pines northward and what to plant in more southern ranges. But some of the other non-commercial species, this is going to be really challenging. Physiological effects of climate change are likely to be important, but in reality, and this is hidden behind me, the impacts of disturbance are likely to be huge and may swamp those biological or ecological response to climate change. So we really need to be thinking about disturbance and how disturbance regimes are likely to change and how we manage for that. So what should we do as natural resource land managers? I would say the best thing we can do is to do our job really well. In school, you're learning how to practice sound forest management to basically keep ecosystems healthy. That involves things like planting species or genotypes in the right place, managing density so that stands don't become overstocked, and in some situations doing proper nutrient management. All of that to ensure that ecosystems are healthy and resilient. It's also important to pay attention to research. I've mentioned research again and again in this lecture, and that's because things are going to change. They're going to change during your career. So things that you know about climate change now will be different 20 years from now. You need to pay attention to that research by reading, going to workshops, meetings, basically continuing education. You need to continue using continuing education because you're going to be using adaptive management big time. You're going to have plans for your forests that go decades into the future, and as climate's changing, you're going to have to change those plans. And just you're going to need to embrace that and be up to date on the research, and do that. But that's great. You are prepared, you're smart, and this is going to be a really exciting time. And what this means is that natural resource managers are more critical than ever for the well-being of society, because we're going to be critical to ensuring that the natural resources we depend on remain available and producing benefits for society into the future in a changing climate. We can do that.